Today, optical fiber is present in our everyday lives. We have high-speed internet and cable TV. It connects our hi-fi equipment and DVD players, and it has a lot more uses which we cannot see. The great development of telecommunications is possible thanks to optical fiber and its enormous capacity for long-distance transmission. We will try to show you what the secrets of optical fiber are. Light waves belong to the same group as radio waves, electromagnetic energy. These waves can transmit all kinds of information, radio, TV and telephone signals, data, etc. The picture shows the very small area occupied by the visible light in the electromagnetic field. In other larger areas lies the spectrum of radio communications. The propagation of light through optical fiber conductors is based on the reflection which light waves suffer when falling on the boundary between two media of different densities. To understand this phenomenon, we will have a look at the properties involved, reflection and refraction. According to Snell's law, when light passes through two media of different densities, it suffers a change of direction. The refractive index is determined dividing the speed of light in a vacuum by the speed of light in the medium, water, glass, etc. Snell's law states that the sine of the angle of incidence multiplied by n1 equals the sine of the angle of refraction multiplied by n2. Depending on the angle of incidence, part of the light ray could be reflected, and part of it could go through the medium. A light beam projected onto a medium of higher density, in this case water, with a big enough angle of incidence, the beam can be reflected completely. This physical principle is the one used with optical fiber. The optical fiber is a filament-shaped waveguide, usually made of glass or plastic, which can conduct a simple light signal introduced with a laser or a lead. However, it is necessary to have a special light source. On the one hand, it has to be a narrow beam which cannot be dispersed, and on the other, it should be consistent, that is, the waves that form it must be equal. The optical fiber can be made of synthetic materials or glass, the latter being very abundant in nature. It consists of two layers of different density and therefore with a different refractive index. Light is transmitted through the interior without the possibility of escaping, constantly reflected. There are two types of fibers, multimode and single-mode fibers. Multimode fiber allows the reflection of the light beam by many possible paths, that is to say, by many light modes. However, it supports less distance. Single-mode fiber allows a single mode or path for light, which can travel greater distances. In this experiment, we modulate the light beam with an audio signal, and at the other end, we demodulate it, obtaining the original audio signal. We've assembled a simple optical fiber transmission system. We have a signal generator, a power supply, and an oscilloscope to display the received signal. These are the optical fiber transmitter circuits, with wavelengths of 800 and 700 nanometers. On this other side, We also have optical fiber receivers, 800 and a 670 nanometers, which can receive the light emitted. We injected a 300 Hz wave in the transmitter circuit. It passes through the optical fiber and it is collected by the 670 nanometer receiver or the modulator and can be seen in the oscilloscope. As the emitted light is 670 nanometers, it falls within the visible electromagnetic spectrum, and it can be seen as red. Now we have changed the frequency from 300 Hz to 3 Hz, and we can appreciate the flicker of the light transmitted. Now we set the transmitter signal generator at 800 nanometers, and we can see on the oscilloscope that the light is invisible to the human eye, because it falls beyond our visible spectrum. To connect the optical fiber, a great variety of connectors was created. The most common connectors are the SD and SD1s, often used in local area networks. The SD connector resembles BNC coaxial connectors and requires a turn for insertion. The SD connector is of direct insertion. One can also use the mechanical couplers, devices that join two fibers mechanically. There are many solutions to distribute fiber signal depending on the manufacturer. The fibers used in long-distance telecommunications are always glass ones. Plastic fibers are used in short-distance applications for a communication channel in which data is sent and received. Two fibers are used, one for sending and another for receiving. We are going to show the most advanced method for joining two optical fibers. The connection is made by melting the fiber material at high temperature by means of an electric arc. The first step is to remove the cable housing and clean the exposed fiber with alcohol. Now we use a high precision cutter to give the fiber the right length. We place this end of the fiber in the fusion machine. We proceed in the same way as before with the other end of the wire. We remove the housing and clean the fiber. And we cut this end with a precision cutter tool. We place it in the fusion machine and close the compartment. In seconds, fiber fusion is achieved. The machine indicates that the operation was accurate, displaying 0 dB. The resulting attenuation is very low, under 0.1 dB. In the coming years, we will continue to see this telecommunications revolution. A future full of possibilities will open up. Real-time TV, telemedicine, video conferencing, etc. Our world will become more and more united through optical fiber networks.